Question 6. A student investigates resistors connected in series. They've got a 3-volt battery, we can see that there. A 22 ohm resistor, we can see that there. And a resistor marked X, there we go. The student does not know the value of the resistor marked X. They decide to measure the potential difference across it. Figure 15 shows the circuit. The circuit is connected incorrectly. Describe how the student should make the correct. Well, if this was an ammeter, perfect. The ammeter goes in series to the components, it goes into the circuit. A voltmeter has to go around the component. It's measuring that energy difference before and after the component. So we just have to say, well, we don't want it there. We want it around here. And there we go. Put that into words. A voltmeter should be connected in parallel or around the component to be measured. So move it to there. There we go. Next one. The student corrects the mistake. The voltage is 2.1 volts and we know it's a 3-volt battery. So if I go back to the diagram, get rid of this. So we've got 3 volts that's got to be shared into each of these. And the question tells us that X has 2.1. Well, if that's got 2.1 of it, then the rest must be here, 0.9. And that's because the voltage is shared between the components and it's got to add up to what's at the battery. So 3 take away 2.1 equals 0.9. Next one, I keep saying this is your most important equation for this. It comes up all the time. I'm very rich. So we've got the current, I, we've got the voltage, V, calculate the resistance, R. So show that the resistance must be 50 ohms. We want R equals V divided by I. So we're away. R equals V over I. Then we take the voltage that it has, 2.1. It tells you what to use. Divide by the current, 0.041. That now gives you 51.2. Yep, that's roughly 50. Done. Next one, calculate the power in a resistor when the voltage across it is 2.1 and the current. So we've got V, we've got I, and we've got P. And you know to use I, P violently. So now we're away and want to calculate the power. So P equals I times V. So P equals I times V. Take the 0.041, multiply it by 2.1, and we get our answer 0.0861. Done. Calculate the overall resistance of the 22 ohmed resistor and resistor X. So what do we need to know? Well, we know that the 22 ohm is 50. The other one is 22 because we calculated the 50 before. Obviously, if you use the 51.2, they'd give you the mark. So now we just add the total resistance of those because now we've worked it out is 72 ohms. All done.